those instead.
Passion cake.
Or chocolate tart. So the reason for the cake is to celebrate. And we're celebrating that we've just paid the mortgage off after 23 years. Get in. So we now own our own house. There ain't many people that can say that. Not at our age today. And it's raining. Ugh. Horrible wintry weather. A cold November evening. Next home again. Time to try some samples. Actual bed studs these are, they're not the ends.
Yeah, these are. See, that's it.
This one?
Yeah.
Okay. It's quite dark.
It's not going to go with that, is it?
That's not going to go, no. Goes with that though.
So it would go with that.
Yeah.
But it doesn't go with that at all.
It doesn't go with the pink one.
So it's too light.
Yeah. So there you go.
Can't have that now.
I preferred that one anyway. That was always my choice.
That was your favourite. The Vello grey bed and headboard and the Italia bed. So Novello, so that was the one that sold. Do you think that would be alright then?
Yeah. That's a goer.
I mean, these have got goldy bits around.
It does. Are these the ones you're looking at?
No,
The different sorts,
I'm
aren't
looking
they?
at just like square. I'm just looking at the glass block square ones with the square.
Just go, isn't it?
I think so.
Yeah. That goes nice. The bed. Goes well, doesn't it?
What, the white?
Yeah.
Do you think the white's better than the glass though?
Possibly, yeah. Yeah, they have, haven't they?
Do you think it's better with the white gloss than with like a glass?
Might be.
And then a mirrored effect. See, that was my original. That was my original thing, you know, with the bed. That the bed would look better with
Contrast.
with the white, because I said to you in the book we've got it with the white. That's what I said. Really perfect. It's really perfect.
Go on, just.
But I just want to, because that's more the sort of thing you'd go for, isn't it? I need something.
No, put it. So it's behind the lamp. That'll be on the stove thing.
Bed sample that. I'll go get some. I'll leave my bag.
Yeah, one of those things where you come to a decision and then it's like, oh, I don't really like that, I'm not sure. Sure that goes. Put a bit of light on the old subject. Now we've got to find a black pad. We need a new linen basket. We needed one for ages, but it's got to fit in a certain space. It's not that big. It costs a fortune. We do one here. It's got 20 quid in it. I can't find it. I think it's just a display one only. But it's ideal. We just fit in our wardrobes. So that's what we're looking at now. Can't see any others there, so I'm thinking it's just a display one for 20 quid, because the others are like 65, but they're a different size as well. And it was gone. Just taking it away, gone to find out. Might even be another one. Oh look, this will do Nicola. And they are all 20 quid then, they're 20 quid. So it's just in case they haven't got any separate. Stacked. Not got any in stock, probably just got display ones. The turquoise ones have got loads. Yeah, TVs for the bedroom. Look, these are ours. That's nice, isn't it? White Samsung. No, that's so LG. Samsung, look. It's not bad, is it?
Right, £3.49.
Yeah. LG.
Buy now, pay later.
Yeah, even Sony. 32. Yeah. Can't beat some good old curry. We were going to go out for a meal. Changed your mind now. Just fancied one of these with a bottle of wine. Ideal because Jack's not going to eat any because he's at Nick's. Cool. Try this. Oh.
Is it hot? That's the madras.
Hot and hot.
Oh,
Madras. Hot in temperature and hot.
Hot. Oh,
It's down like this one.
the kick to it, that one.
That Madras, I've got a kick to it, definitely. So this is a chemistry mock exam, AS level, homework and revision.
Homework revision?
Well, not homework, no, it's not homework revision, it's actually a revision. Because it's not been assigned to you, it's just up to you whether you do it or not. So this is, what's the subject here?
Chemistry.
Oh, chemistry, yeah. And what are we, within that though, what are we studying?
2.1. Polymer waste.
Poly what?
Polymer waste.
Polymer waste. What the heck's polymer waste?
Well,
so you're going to have to teach me this, yes, so that you can
yeah, to a
understand it and it sinks in.
level.
So what's...
I'm just going to scan out some things first. It's down as well, so I can do it.
So you can teach it to Grandma as well. She'll be watching and interested.
Right, so that's as a fuel source. Right, I'll do a brief introduction.
Go on then.
So basically, it's as simple as it sounds. Polymers made from monomers and whatnot. Don't need to go into that, but they're not necessarily good for the environment, and they're not really biodegradable or anything like that. So they just sort of sit in landfills and can be toxic to.
So what are polymers? Pyjamas.
Well, they're like specific types of plastics. They're monomers,
Right. Okay.
which are hydrocarbons, but they're chains of them, so they've all been linked together. And if I could find you the page, I'd quickly flick to it. But I don't think I can. Well, that is. See, there's a monomer and turns to a polymer. But it's a different thing.
Okay.
So this is simply all about different ways to stop polymers from being such a problem when disposing of them. So our first heading is the whole polymers as a fuel source, as it says in this book. Right, so burning polymers under controlled conditions produces heat energy which can be harnessed to make electricity. So this actually uses the polymers to get some of the energy back out and to then reuse it. Agricultural plastics such as polyethylene have long been used to cover crops in the growing season. Okay. Now these plastics are being turned into, I don't even know how to say that, briquettes. What are they? Briquettes. Never seen it, and burned to produce heat. A South Korean company is now working on similar technology to generate electricity. A process that burns old rubber-based tyres is also being used to generate electricity. This has the added bonus of removing unsightly car tyres from the environment. The first plant in the UK was in Wolverhampton, and there are several more worldwide. So, simply, key points, simply burning plastic. Funnily enough, it doesn't really talk about the environmental effects of that. Right. I think I'll look in the book as well. See, you know how we were talking about electrophilic addition reactions a lot?
Mm-hmm.
Well, this has a book. So, let's say we have our alkene. I think it was like something like propene. Well, let's just say ethene. Let's go with that. So we have our ethene. Associated with 1C. That's just the two. So there is our ethene, and we have. So let's say we use bromine. So Br, and one of them will be slightly, positive, slightly positive on that one, and slightly negative. And the reason why they do that is because the electron density and the electron clouds sometimes go over to one side, and they induce a dipole on the other one. Basically, this becomes ever so slightly negative at some point, and causes that one to become slightly positive, and it causes a chain reaction in all of them, which is what Van der Waals forces of attractions are between molecules. So, just checking here. Yeah. So here we draw electron movement. So we draw an electron from the double bond, and then also from this one to
Pay attention.
from this one to the bromine, and that is the electron movement. So, as you can see, the electron is moving from the double bond because that's got a lone pair of electrons spare, where it's bonding with itself. This doesn't know what to do with them, which then is attracted by the slightly positive bromine dipole there, and then the electrons go towards the other bromine because of that, because making that slightly negative. Then this means that it looks like this. So there are our hydrogens. It's starting to look a bit more like an alkane now. And that is not H now. Sorry, that is Br. And there is positive. There's a positive charge there because there are some unpaired. Well, it's missing some electrons basically, and this is now Br minus, and it has a lone pair of electrons which need to be bonded. So, as you can guess, we need something that needs something to make it a little bit more negative, i.e. it needs more electrons, and we have something with too many electrons who doesn't know what to do with them. So, naturally, this happens, and the electrons move to there. And the electrons move to there, as we know, that causes a bond, giving us our final product of dibromo 1,2 methane. Yep, I think so. Next we start ethane. Sorry. 1,2 dibromo. 1,2 dibromo. Ethane bonds up, and that is an electrophilic addition reaction.
So what's the next bit? Next bit is a little while on now, but
I was saying we're moving on to nucleophilic substitution reactions. I was saying like a long words in chemistry, and to explain the terms from electrophilic addition reactions, electrophilic basically means electron loving. So they are things that want an electron. So it's, for instance, as you saw with this, with the dipole for the bromine, it wanted an electron, it drew it towards it, and it was electrophilic. It was generally electron loving. However, nucleophilic is the opposite, and that is when it donates an electron pair. So, for instance, I shall use the example here, and it happens in halogenoalkanes. So if we were to use our product that we made here, just the camera doesn't know this one, but we made this one. So we would find CH3. Oh, I never named this one, did I? I'll name it now. So that is 3, 4. It's 3. What was that element called?
Which one is it? The bottom one. After like AT.
Ato, I reckon. 4. 3 acetate, 4 iodo. Butane. Yeah. So we have our 3 aceto, 4 iodobutane. Yep, CH3. And we'll find, because the halogens are more electronegative, that they'll... Oh, I've drawn the same thing twice. That they will pull the electrons towards them, making them both ever so slightly negative, I believe. Yes, which makes those ever so slightly negative, and that ever so slightly positive. Yeah?
Mm-hmm.
Do you get how that works? pulls the electrons towards them, which are negative. Now, we have our nucleophile, which is our electron donator. In this case, we shall use hydroxide ion. And so, this then, this is quite a simple one to draw out. It simply donates it to the slightly positive carbon. So this, because this will be the most negative, the iodine one out of the whole thing, this will then become H3C, CH3, H, and then OH. So it's now actually an alcohol. So this would be 2 astato and bute and 3ol, I think it would, or maybe it would be, I think it would be 3 acetyl butane 2ol. Yes, that should be what it is, I think, in a word. But now this one can even undergo nucleophilic substitution reaction again. So we have our, let's draw it out like this, 3, 4, OH, AT. I'm just going to do that for all the hydrogens, you get the picture. So there is our OH, and that is still slightly negative, making that still slightly positive. This one's been sorted now, this one hasn't. So we have a nucleophile again. Oh, I forgot to draw the arrow in. And this is going to be awkward to draw an arrow around, but it goes to the carbon. And this whole thing will then become 1, 2, 3, 4. And on those two there will be OH. And this will then become it will become butane 2, 3 diol. Yeah. And there you go. Nucleophilic substitution reactions within your own bloodstream. You're actually doing the reactions.
If you ever get stuck on this subject, you know where to come. Straight back to this video.
On this very specific mechanism subject.
Yeah.
I've still got to do writing them out yet. There's still more to do, but that was the drawing of it.
How windy is it here today? It's had a load of leaves just go flying around. Woohoo! Fair to say, the stormy weather has arrived.